I have a simple Django application that will output the list of posts. It has only a single view, which is post list. And it has two models, one for the post and one for the author. And, with the Docker Compose we have two services, one is Python web service, and the other is Postgres database. Let's trigger Docker Compose up build. We can see that when the web is triggered, all the migration is run, and a super user is also created. Now let's navigate to localhost 8000. If we go to /posts, there are currently nothing as the database is empty. So now we will go to /admin to add data there. In our Docker file we already set the entry point to our init.sh. So when the container is created, this init file will be run. It has the command to created super user here. The command does not specify password because the password will be read from the environment variables without the need to specify. Now we are in the admin site, there are author and post table. Let's try to add some data there. Let's create an author, Amanda Black, 35 years old. Another one is Jake Black, 40 years old. The third one is Summer April and also 40 years old. Then we go on to create some random post like this. Now if we navigate back to post URL, we will see the list of all the post and the author. So everything is working nicely. However, with a database Docker container, we have the problem that if we for some reason clean up the volume, we might lose all the data. And here of course it would not take us that long to fill in the database again. But there might be cases that we have a big database, and adding it manually is not a fun task to do. Or we might have a team of developers, and we want all of them to have a seed database to start with. You might not want every developer need to fill in their database manually, right? That is why we should have a Postgres container that will load the seed database when it starts, so we will not need to worry about losing our data, or sharing it to multiple developers. We already have our database currently filled in, so now we need to extract that data into a backup that we can load into the container whenever it starts. To extract the backup from the database we can use pgadmin. Go on Google and search for pgadmin. Then go to download and choose the correct version according to your operating system. After you install the application, start it up. Go to server, choose register, server. The name here is what we want to call the server instance. You can name it anything you like. I can name it test_db, the same as the name of our database. The host here is localhost. If later you try to connect and it fails, you can try to use host docker internal. The username and password for the database can be found in our Docker Compose file. We just need to copy the information. I think I need to change the name to test database too, as I already registered the test_database before. After filling all the information, click save. If there is no error pop up, then the connection is successful. From the test DB, right-click and choose Backup. Choose a name for your backup. I simply name it dump.sql. One notice here is that you need to choose the format of the backup as plain, or else later the restore database will throw error. Then select where you want to store the backup. For convenient, I store it in the same place as my Django application. To load the dump.sql, we first need to create an init_db.sh. It will basically just grant all permission on test_database to Postgres user. And run the command to restore the test_db with dump.sql. Next let's add a docker file.postgres. In this Docker file let's add the init.db we created earlier to Docker entry point init folder, which is a special folder in Postgres image. All bash file that is in this folder will be triggered automatically when the container is created. Finally, we just need to make a small change in our Docker Compose. Instead of reading from Postgres 12 or latest, now we build the container from our own Docker file, which is dockerfile.postgres. Let's try what we have done so far. First, run the Docker Compose -v. This command will clean up our volume and the data that we created earlier will be empty. If our seed database works, even though we clean up the volume, when the application starts, all data should still be there. Next, let's run Docker Compose up build. You can notice that now when the DB container runs, there is more commands such as alter table, create index. These are the signals that our seed database is being applied. After the container successfully starts, we navigate to Post's URL and refresh. We can see all the data still persist. And navigate to admin site, we can see that both the author and post tables each still have 3 objects that we entered earlier. So we have successfully created a Postgres container with seed database that can be shared among developers and can be cleaned up whenever we want. Thank you for your watching.